Hey guys, welcome to what you need to know for the work, power, and energy. Okay, for tomorrow's physics test. Okay, so work, power, and energy. So that's basically elastic. Okay, potential. Okay, Okay, so power, work, and then basically your EK, your EP. So EK equals to half mv squared, and EB EB, and EP equals to mgh. Okay, so what will they ask you? Okay, so I'm going to start with the calculation based questions, and I'm going to move on to the theory based questions. Okay, so calculation based questions. Okay, they're gonna ask you. So I'm going to start off with the easy ones. Okay, so easy ones may be like spring constant. Okay, so this is, for example, they're gonna ask you, they're gonna tell you a force exerted on a spring, and the compression, and they want you to find the spring constant. Okay, so basically you use F equals to kx. Okay, so F divided by k equals to x, F divided by x equals to k, or kx equals to F. Okay, so you use this formula to find the spring constant, or you use this formula to find the compression distance, or you can use this formula to find the force, given that you have at least two of the variables. Okay, so you have two variables, you can find out the third one using the formula. Okay, that's basically what I'm trying to say. Another question. Okay, so this is a really common question. Okay, so they're gonna ask you, for example, what max speed can object reach after release of a spring? Okay, so basically they're gonna tell you the spring okay, they might, so first of all, okay, and they probably tell you the spring constant. They'll tell you for example, they'll tell you the force, and they'll tell you the compression distance. Okay, and all you have to do is elastic potential energy equals to half kx squared, and then you'll do EP equals to EK. Okay, and then you do EK equals to half mv squared, so therefore 2EK divided by m equals to v squared, so square root of that equals to v. Okay, so for example, they're gonna ask you this. Okay, so how am I gonna word this? So okay, Billy jumps on a the spring constant may be 12,000 Newton meters. Billy is 40 kilograms, and you can say okay, we don't need the compression distance actually. No, they might not tell you the compression distance. Okay, you don't need the compression distance. Okay, so basically, okay, so what is the max speed? Okay, so basically the first thing you gotta do is you're gonna find EP. Okay, so EP equals to half kx squared. Okay, so right now you don't know what x is. Okay, so first thing you have to do is F equals to kx, and you know, because Billy jumps on a trampoline, it's a weight force, so therefore 40 times 9.8. Okay, 40 times 9.8 equals to spring constant. Okay, so therefore 40 times 9.8 divided by 1200 equals to x, okay? Okay, I don't have my calculator with me right now, so I'm not going to be able to do the calculation, okay? But you just plug that into your calculator, it doesn't really matter, okay? So now we're going to say EP equals to half kx squared, okay? So now EP equals to half of 1200 multiplied by 40 times 9.8 divided by 1200 squared will give you an EP, okay? Now EP, so after you found out EP equals to EK, so now we can just say this, okay, this number equals to EK, so we just say whatever this number comes to, we'll say EP equals to half mv squared. So not EP, so EK equals to half mv squared, okay? So therefore 2ek divided by, so mass was 40, so divided by 40 and square root will give us v, okay? So this is how you would find the velocity of an object given the spring, okay? Given in terms of a spring, okay? Yeah, I don't think there's too much questions for involving the calculations for work, power, and energy. I mean, work and power is basically what you learned in level 1. It's not too much, so you should understand that, okay? So basically, it's just going over the springs. Another question I'm gonna ask you is, what is the maximum height that the ball reaches given that when a spring is released, okay? So instead of doing EP equals to EK, you'll just do EP equals to EP, okay? So half kx squared equals to mgh, okay? So this is what you'll use, and then you'll say half kx squared divided by mg equals to h, okay? So this is what you'll use if you want to find the maximum vertical height that the ball, not the ball, but what the object reaches after it is released from the spring, okay? So first you have to find the elastic potential energy stored, and then you'll convert that elastic potential energy into gravitational potential energy, and then you'll find the maximum height, okay? So assuming that EP equals to EP. And then to find the spring constant, F, you'll just F compression distance or spring constant, you'll just use F equals to Kx. So we just rearrange this formula to find for any of these three, okay? So F divided by K equals to X, F divided by X equals to K, and Kx equals to F, okay? Alright, so there's going to be more theory questions, okay? Let me think of some theory questions. So sorry guys, just let me think for a second. I need to try to think. There's definitely some theory questions with work, power, and energy. Okay, so a possible question is what does increasing the spring constant? Okay, so increasing the spring constant makes the spring stiffer. So therefore, more force required to compress or stretch, okay? And F equals to Kx. We'll explain that. So if K goes up, okay, if K goes up, then force required will also go up to achieve the same compression distance, okay? And okay, so one question they might ask you is sorry, this is too big. Okay. Another question they might ask you is what is an elastic what's an elastic what's the word inelastic not elastic collision, but oh, just say elastic collision. Inelastic collision. Okay, so elastic collision is when all of the EK is converted into the elastic potential energy, and all that elastic potential energy is stored. Okay, so all of the EK is converted into EP, but for an inelastic collision, okay, an inelastic collision means that some of the EK isn't converted into EP. So for example, how am I going to say this? So for example, once again, I'm gonna be jumping on the trampoline. Okay, so an elastic collision will mean that all of the EK is going to be converted into elastic potential energy. Okay, and that elastic potential energy is going to be reconverted back into EK when it springs back up. And then elastic collision means that some of that EK is lost. Okay, and that makes it inelastic. Okay. I'm just gonna check. There's definitely a lot of different. There should be. I'm just gonna check. I feel like I'm missing something really obvious. Wait, what? There's actually no spring constant questions. Are you kidding me? Wait, there is. Okay, so yeah, that's basically yeah. Okay. Sorry, just forgive me for doing this. Okay, just skip ahead in the video. Okay, skip ahead in the video. Yeah, I think. Okay, so yeah. So this is the other type of question that you could come across. So, what does stretching the rope do to decrease the force? So basically, you have to relate that back to the impulse equation. So you relate that back to change in P equals to force multiplied by change in time. Okay, you relate it back to that equation. Okay. So basically, you say that when the rope stretches, okay, it actually increases the stopping time. Okay, so some of the EK is converted into EP, and that increases the stopping time, and therefore, linking it back to the equation, you can say that the force decreases. Okay, but feel like I'm missing something. That's why. I feel like I'm missing a question, a type of question they give you. Yeah, I might just be I might just be paranoid right now. I don't think there might not be anything. There might not be anything. Okay, so like I was saying with the inelastic collision, so the collision is inelastic as far. Okay, the collision is inelastic. Okay, so what does that mean? It means not all kinetic energy is converted into elastic potential energy. Some is lost to heat and sound. Okay, elastic energy is when all of the EK is converted into the elastic potential energy. Okay. Oh yes, this question. No, okay, it's not related. It's not related to. Yeah, so yeah, I think that's it really for work, power, and energy. That's it. It's not a very big topic. It's a very, very narrow topic. It's not much in work, power, and energy, but I need to make sure. I'm not like being stupid. Yeah, I don't think there's any more. Yeah, we're gonna yeah, last one. I promise you it's the last one. Ooh. Discuss 2 changes that could be made to the springs of the mattress. Okay, so this is a question we could discuss. Discuss 2 changes that could be made to the springs of the mattress to make Sarah's landing more comfortable. Okay, so one, okay, we could replace for looser springs. So why does that work? So when we replace the springs of looser springs, okay, looser springs, so F equals to Kx, okay, so we can say looser springs, we can say lower spring constant, okay. So if the spring constant goes down, right, that means the force also goes down in order for the compression to stay the same, okay, but the force stays the same. The force stays the same, so stays the same, but therefore the compression distance, the compression distance, sorry, not go down. The compression distance must go up, and the compression distance goes up. That means there's actually more time. So there's actually a higher stopping time. So change in P equals to force times change in time. So by increasing the compression distance, we're increasing the change in time. Okay, so therefore, if we increase the change in time and the change in P is always the same, therefore the force will decrease, okay? And because we made looser springs, okay? So looser springs, so when Sarah lands on it, so it's going to compress more, so the mattress is going to go down more. So the EK is going to become, not the EK, so the change in momentum is going to be changed in a larger amount of time, and that decreases the force, okay? And we can do that by making looser springs and decreasing the spring constant, okay? Number two, we could say, what's another way we could add more springs, actually. We could add more springs. Okay, so if we add more springs, right? If we add more springs, okay, so therefore, if we add more springs, is it more or less? I'm confusing myself a little bit now. Sorry, just let me think. Free. Okay, so we could also think it's remove some springs. So if we remove some springs, we could remove springs, okay? If we remove springs, okay? So let's say there's 20 springs, right? We can say there's only like 15 now, okay? So now Jane's change in momentum is distributed across 15 springs. So it's a lower amount of springs, so therefore there's more force on each spring. So more force on each spring. And therefore F equals to Kx. Okay, so force on each spring has gone up. the K has stayed, so each spring, the spring constant stays the same, so therefore X must also go up in order to match the force going up. And if the compression distance increases, then it increases the stopping time back to our stopping time. And if it increases our stopping time and the change in momentum remains the same, then the force decreases. Okay, so by removing some springs, the average force on each spring increases. So, for example, so it's the same force across less springs. Basically, that's what it is. Same force across less springs, and therefore the force on each spring goes up. Okay, the spring constant of each spring always stays the same, so therefore the compression distance will increase, and if the compression distance increases, then it increases the stopping time, and therefore, because the change in P is the same, the force experienced by Jane will decrease, and her landing will be more comfortable. Okay, so that's the two changes that can be made to the springs on the mattress. Okay, and that's basically like another example of a question. I mean, for work, power, and energy, it's a very like small topic, so it's basically just calculation. It's calculation revolved. So basically, finding the spring constant, the force, and the compression distance using F equals to kx. We're also going to find the elastic potential energy, and we're going to make the elastic potential energy so EP equals to gravitational potential energy, and EP equals to EK. EP equals to EK to find the velocity, and EP equals to EP equals to find the maximum height. Okay. Alright, thank you for watching this video on the what you need to know for work, power, and energy. Hope you enjoyed. Okay, I'm sorry that I spent like 5 minutes going around on tests on my. I should have been more prepared, but I'm sorry about that. Hopefully, you can forgive me for that. Okay, I'll see you in the next video. Thank you.